So we've concluded our notes about the nucleus of the atom, and now we're going to take a look at electrons. So these notes are called Electron Organization. We're going to take a look and see how the electrons are organized outside of the nucleus. Okay, so we know from our previous notes that the nucleus of the atom contains the protons and the neutrons, and we can have different isotopes of atoms because atoms can have different numbers of neutrons. In these notes, we're going to talk about the electrons. So the first question is, how are electrons organized? Here's an example of a carbon atom. Again, we've got the protons and the neutrons inside of the nucleus there in the middle. And then here, and then on the outside, we've got the electrons. Remember, the electrons are negatively charged, okay? And they are in what we call energy shells or energy levels around the nucleus. Alright, so electrons move around the nucleus in energy levels or shells, and each shell has a certain amount of energy associated with it. So the ones that are closest to the nucleus, okay, so this first shell around here in this carbon atom is going to have really low energy. And the farther you get away from the nucleus, the higher the energy is. So that second shell around carbon is going to have electrons in it that have much higher energy than the ones than the shell closest to the nucleus. Here's something interesting to note. Energy shells or energy levels are actually 3D, what we call clouds that electrons move in. So it's like a 3D sphere that electrons move in. But when we represent them on paper, our paper is only two-dimensional. So when we draw them, we actually use circles. So I'll give you an example. So in this picture, we see the nucleus there, again, in the middle. And then we've got rings around it, or circles around it, representing the different energy levels, or the different energy shells where the electrons are. All right, and so we can see that the first ring is called the first energy level, the second ring the second, and so on and so forth. Now these energy levels or shells have a certain amount of electrons that they can hold. All right, and so we can actually see that here in the numbers. All right, so the first one is 2. The first shell is 2. The second shell can hold 8. All right, the third shell can hold 18. And the fourth shell can hold 32. So let's put that down in our notes. So if we make a chart that has energy level or shell number on the left and electron max on the right, for that first energy shell and number 1, it's going to have a maximum amount of 2 electrons that it can hold. Now the second energy shell, or N2, can hold 8. Okay, and 3, or that third energy level, can hold 18. Okay, and then the fourth can hold 32. And so the fifth, or energy shell number 5, can hold up to 50 electrons. So we see as we get further and further away from the nucleus, the energy is going to increase, and the number of electrons that that energy level can hold is also going to increase. Okay, so again, each electron shell or electron energy level can only hold a specific maximum of electrons. And so the electron maximum that we see down here, oftentimes electrons is abbreviated E with a little minus sign by it because electrons have a negative charge. So the electron max in each shell is going to be equal to 2 times the N number, or the shell number, squared. Okay, so we can see that in the second shell, okay, 2 squared is 4, and 4 times 2 is 8. Okay, same thing with the third shell. 3 squared is 9, and 9 times 2 is 18. So it happens in that same pattern for every energy shell that there is. Now we're going to see how electrons are further organized. So we have shells around the nucleus, but we also have what are called subshells. So it gets a little bit more complicated. So let's take a look. Alright, so to get a little bit more complicated, each electron energy level or electron shell is made up of sublevels, or what we call subshells. Okay, so they further organize the electrons around the nucleus. Now we're going to see that electrons in specific subshells move around the nucleus in distinct patterns. Here's a picture on the left that show the different shapes or patterns in which electrons move in these subshells around the nucleus. So, for example, the S subshell, okay, which is right here, this S subshell is a spherical shaped subshell. All right, so here we're going to write down that the S subshell right here is going to be spherical shape. So it's going to be like, in a circle pattern, okay? In a 3D circle pattern or sphere is how those electrons travel around the nucleus in that subshell, all right? Now, the P subshell here is what we call a dumbbell shape, okay? So it's kind of like an infinity pattern or a dumbbell shape. Now, the D subshell is kind of like a whole bunch of dumbbell-shaped, like P subshells all kind of together. So they kind of make like a flowery shape, we call it. So the D subshell has like a flower shape to it. And the last subshell, which is subshell F, is so complicated that it kind of has all kinds of shapes that are, associated with it. Alright, so here we have that down for the F subshell. Alright, so just to kind of summarize again, we've got electrons around the nucleus in what are called shells or energy levels. And each of those energy levels is further divided into subshells or sublevels. And each of the sublevels has a specific letter associated with it, either S, P, D, or F. And these subshells basically have different shapes in which the electrons are going to move within that subshell. Our last questions for these notes is, what does the periodic table tell us about electron arrangement? Now, we know that electrons are in shells and further divided into subshells around the nucleus, but how does the periodic table tell us, give us hints about these arrangements of electrons? It does, and so let's take a look at how it does that. The first and easiest thing that the periodic tells us is the number of electrons for an atom on the periodic table. So the atomic number, remember that top number on the periodic table, the atomic number, is going to tell you the number of electrons in a neutral atom, because remember, the number of protons and the number of electrons need to be equal if the atom is neutral. So that's the first thing that periodic table can tell us about how electrons are arranged in the atom. The next thing that the periodic table tells you is the number of valence electrons in an atom, and this is found in the group A number. Alright, so if we see here, we've got the group number here on top, so that's 1A. Okay, down here it's 2A. All of these transition metals are B's all the way across. Okay, and then we jump back up to here for 3A, 4A, 5A, 6A, 7A, and 8A. Okay, so if it's a group that has an A associated to it, that group number is going to tell you the number of valence electrons in the atom. And valence electrons are the electrons in the outermost shell, and those are going to be super important when we talk about bonding, because those are the electrons that make bonds. Alright, so this rule, again, only applies to the group A numbers. So the transition elements here in the middle, we cannot use that particular rule for. Okay, so we'll find that the transition metals are exceptions to almost everything, and this is the first case. So we cannot know the number of valence electrons in the transition metals, but all other elements on the periodic table, we can tell the number of valence electrons from the group A number. So the first column here, it's in group 1A, so they all have one valence electron. Okay. Group 2 here is group 2A, so they have 2 valence electrons. All right, so on and so forth. So group 3A has 3, 4A has 4, 5A has 5, all the way over to 8A, which has 8. So those noble gases have 8 valence electrons in the outermost shell. Okay, I might as well mention what all of the other electrons in an atom are called. So if they're not valence electrons, they're what we call core electrons. Okay, so all of the other all the other electrons in an atom are called core electrons. They are found in the other inner shells of an atom. So if we need to figure out the number of core electrons in an atom, you would just simply use this equation right here. So you take the atomic number, the total number of electrons in the atom, and then you subtract the group A number, which is the number of valence electrons. So what you'll get is the core electrons that are in the inner shells. So as an example here, here's the picture, and since this shell right here is the outermost shell, we are going to find the valence electrons in that shell. So that's what we call the valence shell, and so we'll find the valence electrons in this shell, and all of the other shells, okay, underneath it are going to have the core electrons. Okay, so that's the difference between the two. Okay, another thing that the periodic table shows us is that as you go across a period, now again you have to skip those transition metals, but as you go across a period, the number of valence electrons increases by 1. So let's take a look. Alright, so again we have the periodic table here. We have our group A numbers. So this first column has 1 valence electron, right? 1 valence electron. That means as you go across, you're going to increase the number of valence electrons. And remember, we're going to totally ignore those B groups there, because the B up here is not going to tell us the number of valence electrons. So we've got in the first column, group 1A, we have 1, group 2A, we have 2, group 3A, we have 3, 4 has 4, 5 has 5, 6 has 6, 7 has 7, and group 8A has 8 valence electrons. So as we go across, skipping those transition metals, the number of valence electrons is going to increase by 1. Alright, another thing that the periodic table tells us is how many energy levels or shells are around the nucleus of a certain atom. Now, this works by going down a group on the periodic table. The number of energy levels or shells is going to increase by 1. So, what that means is the period number is going to equal, okay, this period number right here is going to equal how many electron shells or energy levels are in that atom. So everything in period 1, both hydrogen and helium, are going to have just 1 energy shell. Okay, when we get to the second level, lithium, beryllium, boron, carbon, everything in that second row or second period is going to have 2 energy shells. So if you're ever asked to draw an atom again, which I'm sure you will be, you will know exactly how many rings to put around the nucleus by looking at the period numbers. So if I asked you to create an atom for germanium right here, okay, you could just take a look at the period level 4 and know that you're going to have 4 rings around the nucleus for germanium. Okay, and the very last thing that we're going to put in these notes today is the fact that elements with the same number of valence electrons are going to have similar properties. So what that means is that they're going to make similar type of compounds. So everything in, for example, group 6A right here has 6 valence electrons. And so all of these, because they have the same number of valence electrons, are going to make the same type of molecules, all right, or bonds. and we're going to see that in the next unit when we get there. Alright, so that's all of the notes right now about electron organization, and we'll see you tomorrow for the activity.